We present Fold2Unfold, a screen privacy protection system against shoulder surfing that leverages inner screen reflection on foldable smartphones. Imagine bystanders watching over your smartphone. Fold2Unfold makes screen content visible only to the user while preventing nearby bystanders from seeing it. Fold2Unfold can also be integrated into privacy-sensitive applications like banking apps. Using smartphones in public spaces can expose privacy-sensitive information to bystanders, such as PIN codes or personal messages. Even a brief glance can compromise the user's privacy. Privacy films are common, but offer limited protection, as content can still be exposed by simple tilts or shifts. This raises a critical question. Can we instead leverage the physical properties of emerging form factors to achieve privacy in a more user-friendly and secure way? To answer this, we turn to foldable smartphones, an emerging form factor with two screens connected by a hinged structure. When partially folded, reflections occur between the screens. We use this reflection to reconstruct content only visible to the user. Let's see how this works. Here we have a red square on the left and a green square on the right. When partially folded, the reflected red square overlaps with the green square, making a mixture of the two colors, yellow. Also, their relative positions and shapes vary with the viewing position. Here is a high-level overview. Fold2Unfold decomposes the original content into two shares and displays one on each screen. The system then continuously estimates the user's eye position and hinge angle, updating the warping and projection accordingly. Then, two shares are superimposed through reflection, only visible to the user while remaining obfuscated from other angles. As the user moves, Fold2Unfold updates the warp in real time, so the reconstructed content stays visible from the user's viewpoint. The reconstruction follows the user's eye position, keeping the content aligned and clear as the user moves side to side. However, developing Fold2Unfold raises practical challenges. One key challenge is accurately modeling the inner screen reflection. For a source point on the projecting panel, the reflected point appears at different locations on the viewing panel depending on the viewer's position. Using the geometric model, we back-project the light path from the user's eye to the source point and derive the warping in real time. This allows the content to align only at the user's viewpoint. As the bystander's viewpoint moves farther from the user's, misalignment becomes more pronounced. Next, even when superimposed, luminance mismatch still remains due to differences in light paths. To account for this, we consider two light paths, reflected and direct. The reflected path is attenuated by both the viewing and reflection angles, while the direct path depends only on the viewing angle. By modeling these attenuation and compensating their effects, we obtain the corrected reflection. Simply splitting the content can leave recognizable shapes. Even rectangular fonts can leave residual contrast. To address this, we use camouflage-based obfuscation. In the decomposition step, we use additive light mixing, which allows multiple combinations. For simplicity, we first consider grayscale, but the same method applies to each RGB channel. If we split randomly, some digits are still recognizable. This is because background blocks is brighter than font blocks, so their splits also tend to be brighter, leaving residual contrast. In a decomposed Fold2Unfold share, the digits are difficult to recognize. Fold2Unfold samples one of the background block as if it were a font block. We call this camouflage blocks, which are indistinguishable from font blocks. Using the digit 4 as an example, let's see how this affects visibility. For evaluation, we assume a threat model with bystanders at 4 nearby viewing positions. We ask participants to guess the keypad sequence, allowing them to lean, tilt, or move around. The participants inferred only 0.65 digits on average from a scrambled 10-digit keypad. We compared Fold2Unfold with a conventional privacy film across viewing angles from -45 to +45 degrees, both horizontally and vertically. The privacy film stays readable within about ±30 degrees, while Fold2Unfold reveals the full keypad only from the user's viewpoint, which the user's own head occludes. Please refer to our paper for more technical details and evaluations. Thank you for watching this video.